Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Al-Amin bin Muhammad Shukri.
And my name is Muhammad Shafiq Ibn Surani. I am from CS249 5B2.
And today, we will present about one of the section in algebra structure, which is cosets. Cosets, let H be a subgroup of a group G, which may be of finite or infinite order. We exhibit a partition, a G, by defining an equivalence relation on G. The theorem said, let H be a subgroup of G. Let the relation be defined on G by a relation A on B if and only if a inverse of A on B is an element of H. Then the relation is an equivalence relation on G. Let's discuss more deeper. Cosets are subsets of the group that simply partition the group, dividing it into even sections. For example, if we have an integer modulo 12, so we have the element is 0, 1, 2 until 11. And let's say the subgroups generated by 4 is 0, 4, 8. And then when we add 1 to the subgroup, we will get 1, 5, 9. And when we add 2 to the subgroup, we will get 2, 6, and 10. And then when we add 3 to the subgroup, we will get 3, 7, and 11. So we can say that the subgroup 4, 1 plus subgroup 4, 2 plus subgroup 4, and 3 plus subgroup 4 are all cosets of integer modulo 12, since the partition of integer modulo 12. There are two kinds of cosets, left cosets and right cosets. The left cosets are called left cosets since the number is added on the left, and then the right cosets is called right cosets since the number is added on the right. But let us remember, left cosets do not always equal right cosets. Let's go to another example. How to find all the cosets of subgroup multiple of 4 integer. So first, we have to know the list of element in the integer. So we assume it is infinite integer, so it will have infinite element. So multiple of 4 integer when plus to 0, we will get the element negative 8, negative 4, 0, 4, and 8. And then after the multiple of 4 integer plus 1, we will get negative 7, negative 3, 1, 6, and 9, and so on. And then when we plus 2, we will get negative 6, negative 2, 2, 6, and 10, and so on. And when we plus 3, we will get the negative 5, negative 1, 3, 7, and 11, and so on. So we have partitioned all the integers, or we can say that we have found all the cosets. Last but not least, when we talk about cosets, we have to know what is the index. So what is the index? The index is the number of cosets it takes to partition the group. And then let's find the index in subgroup generated by 3 in integer modulo 24. We know that when the subgroup generated by 3 in the integer modulo 24 is 0, 3, 6, and the large number will get 21. And then when we 1 plus to the subgroup generated by 3, we will get 1, 4, 7, and the largest number is 22. And when 2 plus with the subgroup generated by 3, we will get 2, 5, 8, and the larger number is 23. So 3 cosets, we will get 3 cosets, and the index is 3.
Okay, thank you, Amin. I will continue on the next part, which is the example of the past year question. We choose question 4A from December 2015. The question is, write the definition of the left coset, then exhibit all left coset of the subgroup 6 integer of 3 integer. The answer is, let H be a subgroup of a group G. The subset AH equal to AH when H element of subgroup H of G is the left coset of H containing A. subgroup 6 times integer equal to negative 12, negative 6, 0, 6, 12, 18, 24, and so on. And the group of 3 integer is negative 9, negative 6, negative 3, 0, 3, 6, and 9, 6, 9, and so on. So 6 times integer equal to negative 12, negative 6, 0, 6, 12, 18, and so on. And 3 plus 6 integer equal to negative 9, negative 3, 3, 9, 15, 21, and so on. Okay, move on to the next question, which is question 4b from July 2017. The first question is, what is the index of H in G? The index of H in G is 6 divided by 2, we get 3. Where did we get 6 and 3? 6 is the element of G and 2 is the element of subgroup H, and we get 3. Second equation is list all the left coset of H in G. Okay, the left coset of H is, the first left coset of H is 1, 2, and after do some permutation, we get 1, 2, and 1, 3, 2. And another left coset of H is 2, 3, and we do some permutation, we get 2, 3, and 1, 2, 3. The third question is list all the right coset of H in G. The right coset of H is 1, 2, and we do some permutation, we get 1, 2, and 1, 2, 3. And another right coset of H is 2, 3, and we do some permutation, we get 2, 3, and 1, 3, 2. The last question is H normal in G. Clarify your answer. H is not normal in G because left and right coset are not coincide. I think that's all from me and Amin. Thank you.